Good evening, ladies and gentlemen. Welcome back. It's been a hot minute, but I'm back here with another video. We've moved on from calculus, and now we're taking some practical classes here. And anyway, this is a pretty stereotypical circuits problem that you'll probably have that has to do with equivalent resistance. Now, right off the bat, looking at the circuit, you see that it looks like kind of a hot mess. You have like 8 different resistors that you might have to take into account, a bunch of lines all over the place. It looks really interesting, but I will show you how to break this down and eventually get the correct answer from this circuit. So first off, let's look at where all the resistors are. You see we got ones here, here, here. These are all in series of each other, but right here we have just a wire with no resistor on it. So this means that if the current is coming here, pretend the current is coming this way, it's always going to take the path of least resistance, okay? It's not going to go straight into this resistor. It's going to take a right here, and it's going to continue to go down this way. So that basically eliminates this whole part of the circuit because this is a short right here, it shorts it. So we can just essentially cross all this out. This isn't even important anymore. Now we need to focus on this sector of the equation. As you see, we have a 53 ohm resistor going this way, and then a 91 ohm resistor that the current traveling will go here. It's going to go around, and it's going to go back through this other 91 ohm resistor. Now, essentially, these resistors are essentially one resistor, both 91 ohm ones, and since they're both basically one resistor, they run essentially parallel to this 53 ohm resistor. Now, if you notice this equation in the corner, this is where we're going to be able to use it, okay? So let's have resistor 1, R1, be the 53 ohm resistor. So we have 53 on top. And R2 is going to be both of these 91 ohm resistors. So it'll be 53 times 91 plus 91 because there's 2 resistors. Now at the bottom, it's going to be divided by 53 plus 91 plus another 91. And using this equation with these parallel resistors, we should be able to get the equivalent resistance of these 3 here. Now, plug into your calculator, you should get about 41.047. I'm rounding to the 3rd decimal point. In my homework, the professor tells us to round to the 1st decimal point, but it's kind of a janky website, and you might get it incorrect if you just don't round it, if you do round it to the 1st point. So it's always safe to have some extra figures on the number. So now that we've done this equation, we know that all 3 of these resistors are essentially one resistor that is 41.047. Okay, try again. Now that we have done this math, we can see that all 3 of these resistors are equivalent to 147.047 ohm resistor going across here. And the rest is pretty simple. All of these, there's just one path for the current to take. It's going to go right. Since we got rid of this whole thing here, it's going to take a right, it's going to go through this one, it's going to take another right, it's going to go through this one, and then it'll finally terminate at B. So this next part is pretty simple. Since they're all in series with each other, we just simply need to add them up. So 77 plus 96 plus 41.047. And that should give you 214.047. On my homework, the correct answer was 214.05. I still got it correct. I just had a lot more rounding stuff. But this is the ultimate answer for this equation. All of these resistors are equivalent to 214.047 ohms of resistance. Thank you for watching, and I hope I helped you out, I guess. All right, until next time. How do I stop? I forgot to turn this off.